how do you say that?
Cycloalkane.
Yeah, so I just drew like yeah, I didn't draw the structure, the skeleton structure for that one, or the compound. I just did the like a ring for
the bond line drawings.
Yes.
Okay.
Oh, no.
Okay, so you guys there? Can you hear me okay?
Yep.
Sweet. So lab 1 is an esterification. And if you did your pre-lab, you should know what that means. Basically, we're making an ester. And we're doing that using Beyond Labs because we can't do the experiment in person. So we're going to open organic chemistry. And then in the organic lab, we're looking for the worksheet using thin layer chromatography. All right, so let's try and find that. Every once in a while, Beyond Labs sort of reorganizes where they put things, but we should be able to find that worksheet, Introduction to Thin Layer Chromatography. So I'm going to organic chemistry. And then in techniques, there's using thin layer chromatography, all right? And if we look, the reaction that we want to do is already set up. So esterification is the reaction that we're going to be doing. Good. So from there, we just have to follow the directions in the lab worksheet. I'm trying to make this a little bit smaller.
Is this just what you're going to be going over the next 15 minutes? Is
Yep.
the lab?
Yep.
Okay.
Orlina, you already did this, huh?
I did.
Yep. You're so fancy. You're ahead of everybody. No, that's great. That's amazing. But I just want to do a quick run through to make sure that you know like how to click, because getting it set up is a little bit of a pain in the keister. I think that the lab instructions are pretty good. So Orlina, do you have problems with the lab instructions?
No, I mean, pretty straightforward, especially with like the little pictures and stuff helped as well if I wasn't quite sure of what something was.
And I don't know if I keep on doing the pictures after we've done like 4 labs. You should sort of get the hang of how to put a reaction together. So I'll just do the same thing with words. And after you've done a few of the labs, it shouldn't be any harder at all. But for right now, hold on a sec. What is going on here?
Well, then that, and also as you like scroll over the things, it actually tells you the names of them. So that makes it easier to know.
Yep, absolutely. Okay. Too many windows. I can't find anything. Okay. So note that you're going to have to keep track of how long your reaction takes. That's right here. Unlike in real life, we can actually speed up time. If we want to make 10 minutes elapse, we can click here to forward our clock, and like 10 minutes in real time can go by in the blink of an eye in the lab, which is great because real organic reactions can sometimes take a really long time. So I've had to run organic chemistry reactions that have been like 30 or 40 hours that had to be babied the entire time. So I had to do experiments that were that long where I didn't get to do anything more than like run away to use the restroom or grab a bite for 10 minutes, and that's it. So anyway, it's good that we can fast forward time in the lab here. Esterification reactions don't take that long, normally 20 minutes to an hour, something like that. but it depends on a lot of things. What temperature are you running them at? How much catalyst have you put in? So if you've done your pre-lab, you know what the catalyst we'll be using in this reaction is. Okay. If you ever mess up, make sure you realize that there is an out button for you. So I'm going to minimize this. All right. The out button is the green exit sign. Just get out of the lab if something is screwed up, and you can restart the experiment. It does not take very long to run one of these, so there's no excuse to not do it right. If something's not looking the way it should, just exit and then come back in and start over. All right. So we're going to go to the 2-phenylacetic acid. And once we hover over that thing, our cursor should turn into a hand, and we can click and drag that little scoop of our 2-phenylacetic acid to the round bottom flask. So that's us taking a scoop of that reagent. So where's our 2-phenylacetic acid? There we go. There's our 2-phenylacetic acid. And I'm going to click and then drag a scoop of that over and put it into our round bottom flask. And then we have to find our 3-methyl-1-butanol. So where's that at? There's our 3-methyl-1-butanol. So we're going to take a scoop of that. And since it's a liquid, it's showing as a syringe because we're going to move it as a liquid, which would be a syringe would be one efficient way to do that. So we're going to put our squirt of 2-phenylacetic acid in there. Oh, sorry, that was our 3-methyl-1-butanol, the second reagent. And it looks like now we're going to move our round bottom flask over to the yellow stir plate. So generally when we do chemical reactions, we want them to stir. So this stir plate, we can put a magnetic bar into the round bottom flask and it will spin and allow that reaction to stir efficiently. So I'm moving my reaction over here. All right. So I have both of the two reactants. I have not put the catalyst in yet because I haven't started the reaction yet. Okay, and then I'm going to find my sulfuric acid, H2SO4, and I'm going to put a little bit of that in there. So I'm going to use that same technique where there's my H2SO4. I'm going to take a little bit of that and put it into my flask. Okay, and look, the chalkboard even tells us what things we put together. So I put the 3 things that I need to get the reaction to work into the reaction flask. I'm going to heat this reaction to get it to go faster. So in the end, what we're trying to do is assemble something like this. This is a heating mantle. It's sort of a heating pad that heats the reaction inside the round bottom flask. And then because the reaction is going to start to boil pretty soon, we're going to put a cold water condenser and a nitrogen line in so that the reaction, for one, has nitrogen as its atmosphere instead of oxygen. And also that cold water condenser will mean that if anything in here boils, it's going to condense and fall right back into the flask. So in other words, we're not going to boil away our liquids in here. So how do we get that to work? I think that first we're going to click and drag the condenser over and put it on. And then we're going to click the N2 gas and drag it up to the top there. And that's how we assemble our apparatus for the lab. In order to get the reaction to start efficiently, we're going to have to turn the spinner on to get the reaction to stir. So that's what we're going to do here is start our magnetic stir bar spinning and click start the reaction. So at the beginning of the reaction, we want to sort of look at what things are in the reaction flask. We do that with something called thin layer chromatography, all right? And I'm going to draw some pictures to sort of help visualize what's going on. But here's how we do it in the actual experiment. This is our thin layer chromatography plate, and if we drag it over to our flask, we can see that these two spots are representing the two organic reactants that were there at the beginning of the reaction. And here is what's actually happening as the reaction's progressing. So note that our reaction hasn't been running for very long, but already we see this new spot appearing. So what these spots represent is the different reactants and products that are happening in the reaction. And this new product is moving farther up the plate because it is less polar than either of the reactants. So these are our two reactants in the reaction, and this new thing is our product of the reaction. So if I had done a TLC plate before the reaction began at all, this first lane is what we call our reference lane or our co-spot lane. These are just the reactants of the reaction. And this is the reaction itself. And we can see that we're starting to make a product. So these spots are turning into this new spot. All right. Now, if we let this reaction run for a little longer, let's say for 5 more minutes, we can do another thin layer chromatography and capture the reaction's progress. Oh, so you can see now those two reactant spots are starting to disappear, and we're making more product as time goes on. So when you guys do this, you're going to be taking pictures of the TLC plates as you go. Don't forget to do that, because you're going to have to turn those pictures in to prove that you did the reaction the way you're supposed to. If we go for, let's say, another 15 minutes or so, let's see what happens then. Ooh, now we've got a lot of product, and it looks like our two reactants are starting to go away. We don't have very much of those left. So if we had to guess what it looked like in the TLC when the reaction was finished, that would probably be when one or both of these reactant spots disappeared. So once one of our reactants is gone, we can't make any more of this new spot, the product. So let's X out of that TLC plate, and let's try another 15 minutes. Now, when you actually do the lab, pay attention to what it says for how long you should be fast forwarding each of these times. I'm just showing you the basic procedure. So you follow the directions for how long you wait in between TLCs. After another 15 minutes, oh, we're so close to finish now. Our two reactants are almost gone. There's our product. We have almost all product and almost no reactants. Let's try another 20 minutes. We're so close. Let's try another 20 minutes or thereabouts. That is all but finished at this point. So basically, those two reactant spots, the things that we started with in the reaction, are gone. And now we just have product left over. So if we went for a little bit longer, maybe we could get one of those reactant spots to completely disappear, but that's really close to done. And now you can see complete disappearance of the two reactants and formation of the product of the reaction. So TLC is something that we do to monitor organic reactions as they progress. And the reason we can use it is because TLC allows us to separate the different reactants and products based on their polarities. So the more polar reactant or product is, the less far it travels up the plate in the thin layer chromatography experiment. So in this experiment, these two spots that disappeared were our reactants. They were both more polar than the product of the reaction.
Dr. Musk, for that first picture, you wanted of that TLC thing. Did you want it with that reactant starting or before you hit the
Before you hit the start button. Yeah, I started the reaction too fast. I should have done the TLC plate before I started the reaction
so it
spinning.
should only have the 4 spots instead of the 5?
Exactly. Yep.
Okay.
Before the reaction starts, there won't be any of this product spot at all.
Okay.
So from there, just answer the questions in the post lab, along with adding those pictures of the TLC plates. And that's it for the first reaction. So after people turn those in, like next week, when we get to the 18th, we'll actually talk about what those spots mean and how we would actually do a thin layer chromatography experiment. As a matter of fact, I might actually post a little video of somebody else doing a similar thin layer chromatography experiment so you can see what it looks like when people are doing it in real life instead of just like in a simulation. These are really fun experiments, and thin layer chromatography is something that organic chemists do every day, because when we actually run a chemical reaction, we want to know how it's progressing. And when it's finished, notice that if I do that thin layer chromatography experiment and just check my reaction mixture, I could actually monitor how the reaction was going, how close I was to finished, right? So why would you let a reaction run for 2 days if the reaction was going to be finished in an hour? How would you know it was finished in an hour if you didn't have a quick way to check how much of the reactants and products were left? That's what thin layer chromatography does for us, is it allows us to check on a reaction in progress to see when it's finished. We can tell when it's finished because those reactant spots disappear and we're left with just product spots. Any questions about that? All right, if you guys don't have any questions, that's our tutorial for Lab 1. And hopefully on Wednesday, you guys will have watched through the rest of those Chapter 12 sectional videos. I'll also post probably just one bigger reading quiz for Chapter 12. That's going to make it a little harder for you to get 100% unless you really understand what's going on. But if you have to take it a few times, or if you have to come ask me questions in office hours, that's a good thing, right? I want you to be confident in your responses. So maybe I'll just do like one 10-question reading quiz for Chapter 12 to make sure that you guys are really understanding what's going on. All right, if there's nothing else, have a lovely evening, and I'll see you guys on Wednesday. All right?
Dr. Musk,
Yes.
for office hours, do you want us to sign up with you, or do we just follow the Zoom link during the
So
time?
yeah, just follow the Zoom link. If it's during my office hours, so that's Tuesday, Wednesday, Thursday from 2 to 3:30, I'll be there. All right?
Cool. Thank you.
You're welcome. Have a good evening.